start with derivative of inverse trigonometric functions, and we will solve your derivative of y is equal to cos inverse x. Okay, y is equal to cos inverse x. We need to use the concepts of what we have learnt in your inverse trigonometric functions. Okay, so just do it with me. Let y is equal to cos inverse x. Okay, where you know x belongs to closed interval -1 to 1 and y belongs to closed interval 0 to pi. Okay, this thing implies if y is equal to cos inverse x, then x is equal to cos y. Okay, the small change in x is denoted by delta x. Okay, small change in x, and the corresponding change, small change in y, is called as corresponding change in y. Okay, so that means if say this is the concept here, then x plus delta x means the value of x is changed with a small delta x, then corresponding change in y will be like cos of y plus delta y. Okay, so what does this means? That delta x is equal to cos of y plus delta y minus x. What is this x? This x is your cos y. So I get it as cos of y plus delta y minus your cos y. So delta x is this. Okay, now you know this change we consider is very small. It's such that it is almost approaching to 0. So let limit delta y approaches to 0, delta x upon delta y. What will it become? This will become limit delta y approaches to 0, okay, cos of y plus delta y minus cos y upon delta y. Okay, now what is the formula for c minus c? Okay, what is the formula for cos a minus cos b? It is 2 sin a plus b by 2 into sin b minus a by 2. Okay, c minus c, you remember that formula. So c minus c is either you take it as minus 2ss, okay, you take it as sin a plus b by 2, sin a minus b by 2, or with the negative sign taken common, or 2 sin a plus b by 2 into sin b minus a by 2. In that case, you didn't need to take this minus sign outside. So how can we go for it? I'll go for it as limit delta y approaches to 0. It will become 2 sin a plus b by 2. Okay, and into sin b minus a by 2. A minus b by 2 I'll take, and I'll adjust negative sign here. So it will be y minus delta y minus y, this divided by 2. Okay, y plus delta y, b a minus b by 2, y plus delta y minus y divided by 2. Okay, and divided by delta y. Okay, I'm using it as minus 2 sin a plus b by 2 into sin a minus b by 2. Okay, so in that way, a plus b by 2 and sin a minus b by 2 upon delta y. Okay, so it becomes limit delta y approaches to 0, minus sign can be taken here, 2 sin, it will be your, I can take it as 2y plus delta y by 2 means it is y plus divided by 2 means it reduces like this. Okay, into, now I am going to separate the limits also. Delta y approaches to 0, this will become your, this gets cancelled, so I get it as delta y by 2. Okay, upon delta y. You know, delta y will not be of any use here. This delta y will be, this is sine of, and this delta y will be used here as I have to apply that result, limit h approaches to 0, sine h upon h is 1. You know it very well, because here if I'll put the limit directly, it will be okay, means it will be sorted. So it is minus 2, it will be, I'll put as say delta y approaches to 0. Okay, So in that case, if delta y is approaching to 0, I'll get the result as minus 2 sine y. Okay. For the second case, limit delta y approaches to 0, sine delta y by 2 delta y. Now you know I have to make it like sine h upon h. So I have to multiply by 2 and divide by 2. So this 2 I can adjust here. Okay. So to frame it like the result like, say, limit h approaches to 0, sine h upon h is 1. Okay. Here it is delta y 2. So here also I need delta y. So please check it. If delta y is approaching to 0, what about its half? Definitely it will also approach to 0. So I'll get it as minus sine y. Limit delta y by 2 approaches to 0, sine delta y by 2 delta y by, and this result reduces to 1. Okay, this result reduces to 1 and I'll get it as minus sine y. Now let's get back to y. What was y? Y was your cos inverse x. And this result you have done in your inverse trigonometric functions. It becomes minus times minus from this, and sine cos inverse x under root 1 minus x square. Okay. So what is the case here? That the limiting value of this, okay, limiting value of this delta x upon delta y, it is actually your dy by dx. Okay. This very small change brings the total change. So that means what I got here is, I got dy by dx is equal to, okay, 1 upon dx upon dy. That is minus 1 upon under root 1 minus x square. And you know, when does it doesn't hold? If the value of here x is minus 1 or 1, okay, then this value will not exist. So x belongs to closed interval minus 1 1, and x should not be equal to plus minus 1. Okay, so what do I get? I get derivative of y, who is y? Cos inverse x is your minus times 1 minus x square. Okay, where x should belong to open interval, as the endpoints should not be there, okay, because they are making this denominator 0. So I should get x belonging to minus 1 to 1. So what is the derivative of cos inverse x? It is minus 1 upon under root 1 minus x square. Okay. So this is one way, as we have done in your class 11th, the derivative of trigonometric functions using first principle. In your book, one short method is prescribed, and that method is like your derivative of inverse trigonometric functions. Okay. So let y is equal to sine inverse x is equal to sine y. Differentiating both sides with respect to x, what will I get? 1 is equal to cos y dy upon dx. Okay. So dy upon dx will be 1 upon cos y. Now put the value of y, that is 1 upon cos sine inverse x. Okay. Now we observe that this is only defined when cos y is not equal to 0. So y is your sine inverse x, that is sine inverse x is not 0. When it is not 0? When sine x is not equal to minus pi by 2 to pi by 2, or it is not minus 1 and 1. That means again same as cos inverse x, x should belongs to the open interval minus 1 1, means it should not contain the value minus 1 and 1 themselves. Okay. So again one more result we are going to use, that cos square y is 1 minus sine square y. Okay. That means it can be written as 1 minus sine of the value of y sine inverse x whole square. Now you know what is sine inverse x? It is 1 minus x square. Okay. Now again, since y belongs to minus pi by 2 to pi by 2, so cos y is your positive. Hence your cos y is turning out to be under root of 1 minus x square, means we will not take the negative value. Okay. Therefore for x belonging to minus 1 to 1, the derivative dy upon dx will be your 1 upon cos y. Okay. 1 upon cos y, that is your 1 upon under root 1 minus x square. So this is also one way of doing this question, but I find the first one is very simple.